Okay, this is Tong School End of Year Examination Paper 2 for 2023. Let's go through the questions. Now, question number 1. Kathleen has 1.2 meters of ribbon at first. She used 45 cm of it. What is the length of the ribbon left? Now, if I look at the final answer, they require you to record your final answer in meters, which means I must change the 45 cm to meters. So 45 cm, I change to meters, will be 45 over 100 meters. Then this will give me 0.45 meters. Okay, then I will take my 1.2 minus my 0.45. I'll get my answer, 0.75 meters. So very straightforward for question number 1. Okay, now question number 2. The figure is made up of 3 identical squares. What percentage of the figure is shaded? So if I look at the first square, I cut my square into 4 smaller triangles. Okay, so if one square has 4 smaller triangles, that means if you have 3 squares, there will be 12 smaller triangles. Okay, so total, let's say I assign my 1 triangle to be 1 unit. So I will take 4u multiplied by 3. I get 12 units for my total. So here will be 4u, and then this is my 4u as well. So shaded is 3. 3 out of 12 multiplied by 100%. So you can use your calculator. You should get 25%. So that's the answer for question number 2. Okay. Now question number 3. A machine takes 2 minutes to print 3 posters. At this rate, how many posters will it print in 2 hours? So every 2 minutes, I will print 3 posters. Now 2 hours, I change to minutes. I'll get 120 minutes. So every 2 hours is 120 minutes, because 2 times 60 will give us 120. So we'll do my grouping concept. Okay, so if you want to find the number of groups, I will take my 120 divided by 2 minutes. I'll get 60 groups. Every one group, there's 3 posters. So 60 times by 3, you get your 180 posters. Okay, very straightforward. Now, question number 4. 7 chocolate bars weigh 384.51 grams each. How much do they weigh altogether? Round the answer to the nearest kilogram. Nearest kilogram means the nearest whole number. Okay, so I'm going to take my 384.51 gram. I times by 7 first. I will get 2691.57 gram. If I want to change to my kilogram, you must divide this by 1,000. So if I divide this by 1,000, get 2.69157 kg. Since my question asks for the nearest kilogram, I'm required to change to my whole number. So 2.69, this one if I round off, I will be rounding up to 3 kg. So it's 3 kg to the nearest kilogram. Okay. Now, question number 5. A bag containing 12 oranges weighs 980 grams. Change this. A bag containing 12 oranges weighs 980 grams. The mass of the empty bag is 20 grams. What is the average mass of one orange? Okay, so the bag contains 12 oranges. So this 980 grams is the mass of my bag plus 12 oranges. So bag plus 12 oranges is 980 grams. Okay, the mass of the empty bag is 20 grams. So if I know that the bag is 20 grams, I will minus off to find the mass of my 12 oranges. So 12 oranges will be 980 minus my 20 grams. So this gives us 960 grams. Let's find the mass of one orange, the average mass. So 960 divided by 12. This will give us 80 grams. So that's the answer for question number 5. Okay, now question number 6. In the figure, ABCD is a parallelogram. Now angle, so if ABCD is a parallelogram, means that this line is parallel to this line, then this line is parallel to this line. So you can annotate your diagram first. Now angle ABD is 29 degrees, angle ADB is 38 degrees, and angle BCE is 66 degrees. Okay, so I have all these angles in my diagram. Now part A, find angle BCD. How do I find this angle? Now you cannot assume that your BCE is a straight line unless your question tells you so. So if you want to find this angle, you notice that your BCD is the same as your angle BAD because it's a parallelogram. So angle BCD equals to angle BAD because it's a parallelogram. If I want to find this angle, I will take my 180 degrees minus of my 38 degrees minus of my 29 degrees. Okay, why? Because of angle sum in a triangle. So that shall give us 113 degrees. Okay, that's the answer for part A. Now for part B, circle the words that describe ABED correctly in the following statement. Okay, so ABED, right? Do I know whether it's a trapezium or not? Depends on whether these two angles give me 180 degrees. So if I look at these two angles, this is 113. If I take my 113 plus 66, I will not get 180. So this is not a straight line. Okay, you cannot assume it's a straight line. So if it's not a straight line, means that this line DE is not parallel to your line AB, which means that your ABED is not a trapezium and AB is not parallel to your DE. So you must be very careful. Okay? Now, question 7. Patrick bought 15 rulers and 20 highlighters at $54. He wanted to buy another highlighter but was short of 90 cents. He decided to buy another ruler instead and had 40 cents left. So how much did each ruler cost? Okay, this question, it's a bit like your shortage and surplus. You need to draw your model. Now, do not assume that your 15 rulers and 20 highlighters, this $54 is his pocket money. That's not true. Okay, this $54 is only the cost of your 15R plus 20 highlighters. It does not mean that he has $54. So I'm going to draw my model. So I will draw my model. This is my 15R plus 20H. This is the cost of, this is my $54. Okay. Now I'm going to draw. Now this whole rectangle indicates his pocket money, the total money that Patrick has. Okay, so out of his pocket money, he spent $54 on the 15 rulers and 20 highlighters. Now if I look at the first case, if he wants to buy another highlighter, he's short of 90 cents, meaning he requires an extra 90 cents. Okay, so this is my 90 cents for him to get the extra one highlighter. Wait, hold on. Maybe I make it a little bigger so you can put the dollar sign. So 90 cents, add extra to his pocket money. Then this thing will be the cost of my one highlighter. Okay? Now, he decided to buy another ruler instead and had 40 cents left. So I'm going to create the same model as before. So I'm going to draw the same rectangle. So this is my 15R plus 20H. Okay, this is my $54. If he purchased one more ruler, he has 40 cents left, meaning that the cost of one ruler doesn't exceed the money that he has. So I'm going to cut off. This is my 40 cents. Okay. Now this is the one ruler. So I'm going to label 1R. Can you see? Okay. So once I draw my model, right, do you notice that if I look at this part, if I look at this part, the right-hand side, the front part, they are the same, $54 for your 15R plus 20H. But the back part, you will see that the cost of your one highlighter is actually 40 cents plus 90 cents more than the one ruler. This part. Correct? Your 90 cents plus your 40 cents. So if you want to find the cost, if I want to rewrite this equation, I can say that my one highlighter is equals to my one ruler plus 90 cents plus 40 cents. Okay, so 90 cents plus my 40 cents. So it's 1R plus $1.30. That's the difference in the cost. Okay, so now I'm going to make use of this to rewrite my equation for 15R plus 20H. So if you have 15R plus 20H, okay, I'm going to change the H in terms of R. I'll get 15R plus this 20, I'm going to multiply by 1R. Okay, or maybe I record 20H first if this is confusing to see. Okay, maybe I break this down for you. So you have 20H, I'm going to change in terms of R. So 20H would be 20R. And then your 160 multiplied by your 20. Okay, so 130 times 20, can use a calculator, you get $26. You're multiplying this by 20. Okay, same for this side, times by 20. Then I'm going to change this 15R plus 20H in terms of the ruler. So I get 15R plus 20R plus 26. This equals to my $54. Can you all see? So I'm going to change this. This is my 20H. Correct, I'm replacing with my 20R plus 26. Then if I simplify this equation, we get 35R plus my 26 equals to my $54. So 35R will be equal to my 54 minus my 26. This is $28. Then you can find your 1 ruler. So you divide this by 35, you get your answer 80 cents. So that's the answer for question number 7. Okay, so 1 ruler costs 80 cents. Now, question number 8. Mrs. B had a bottle of syrup. She used 600 ml of the syrup in the morning and 1/6 of the remaining syrup in the afternoon. After that, half of the syrup was left. So how much syrup was there in the bottle at first? Okay, question number 8, right? You notice there's the word remaining syrup. Remainder, remaining means you must draw your remainder model. Okay, so I'm going to draw my model first. So I'm going to draw. I'm going to cut off this to be 600 mils. This is in the morning. So you can put M for morning. Now this is my remainder. Okay, so remainder. Okay, maybe I use, can see, right? Okay, like that. Try my best to draw as straight as possible. Now, 1/6 of the remaining syrup means that this portion I will cut into 6 parts. Now, draw another model below. Okay, I'm going to cut this into 6 parts. Cut into 2, cut again to 3 parts each. So 1/6 is for afternoon, A for afternoon. Okay, now after that, half of the syrup was left. So this part here is my half of the total. So I put half T means my half of the total syrup. So how much syrup was there in the bottle at first? Okay, this one quite basic, the model. So half of my total, if I see my model is equivalent to 4 units. Correct, 1, 2, sorry, not 4, 5. Okay, 5 units is my half total. If you want to find for total, it will be 5U multiplied by 2. You will get your 10 units. So 5U times 2, you get 10U for the whole thing. How do you find for your morning? Remainder is 6 units. Okay, so 10U minus of my 6U means that my 4U is the 600 ml. So 4U is 600 ml. I find my 1U. I divide this by 4. Okay, I'm just going to show straight away. 150 ml. And then you find for your 10 units because your total has 10 units. So 10U times by 150U. Sorry, 150 ml. This will give us 1,500 ml. So that's the answer for this question. Okay, 1,500 ml. My syrup at first. Okay, question number 9. Now, figure ABCDE has an area of 2,140 cm square. ABD and CBE are straight lines. find the area of the shaded triangle BDE. So you want to find this shaded triangle. Okay, now I'm going to assign letters to my diagram so it's easier for you to follow along. So I will let this area ABE to be area X, this to be area Y, and this to be area Z. Okay, you label this first on your paper. So triangle AED, okay, triangle ADE is equals to your area of X plus Y. Area triangle CDE is your area of your Z plus Y. Okay, so if I want to find the area of ADE, I will use my formula half times base times height. Half times my base of 42 times my height of 78. So I get my triangle here to be 1638. Then area of my triangle CDE is half times 42 times 40. So this one will give me 840, 840. So if I take my ADE plus my triangle CDE, right? If I take 1638 plus my 840, these two will give me X plus Y, 2Y plus Z. So this is my X plus Y, right? This is my Z plus Y. All right, from your early on when we record the letters. So if I add these two up, this will be my X plus 2Y plus my Z. This is the 1638 plus my 840. Okay, which will give us 2478. But right now you're interested to find for Y. And the question you're also given your 2140. This 2140 is the whole figure, which indicates that this is my X plus Y plus Z. So you see that this is my X plus 2Y plus Z, and I also have my X plus Y plus Z. This is my 2140. So how do you find your Y? The area that you want to find, you go and subtract. So find the difference. So 2478. Maybe I put Y first. So Y equals to 2478 minus my 2140. That will give us 338. Okay, so it's 338 cm square. Okay. Okay, question number 10. The table below shows the number of books read by 40 students. One of the numbers in the table is covered by an ink blot. So the average number of books read by the students is 7. What is the number covered by the ink blot? Okay, you're given the average. You're given the total number of students. So I can find the total books. So total books will be my 7 times by 40. That will give me 280 books. Then you find the total books read for these students that's given in the table. So 0 times 7 plus my 5 times 8, then plus my 8 times 15. So this is 160 books. So the books read by all these 7, 8, and 15 students is 160. I want to find the books read by the last column, subtract. So 280 minus of my 160. This is 120 books. So this column is 120 books. How do you find the number covered by the ink blot? So 10 students read 120 books. I want to find for one student. So I take 120 divide by 12. That will give me 10 books. Sorry, 120 divided by 10. That will give me 12 books. So the number covered by the ink is 12. Okay.
Okay, let's take a look at question 11. So ABCD is a rhombus, and they say angle BAD is 55 degree and DEC is 90 degree. So immediately when I see the 90 degree, I will start to annotate that first. Okay, so I think it's something that we should write down. So 90 degree like this, just draw a right angle. All right, and they ask us to find angle ADB. Okay, so for angle ADB, all right, so first we must understand what are the properties of a rhombus first. Okay, so a rhombus, what we know is that it has 4 equal sides. All right, all the 4 surrounding sides are the same size. And also there's another thing we know is that for a rhombus, there are 2 sets of parallel lines. Okay, so you notice that these 2 parallel lines, A, B, and DC are parallel. They are connected with this third line here. So you notice there's a Z-shaped property that you can possibly use. Okay, so that's one. All right. Yeah. Okay, so I think what we should do is for rhombus, normally I will prioritize labeling equal sides first. The reason is because for equal sides, right, it is easy for you to tell for observe isosceles triangles. So AB, this, okay, this one I'll just use this side here like that and like this. Okay, so notice all 4 sides are now the same. Let me just re-annotate this. Okay, all 4 sides are equal. So that tells you that angle ABD is an isosceles triangle. BCD is also an identical isosceles triangle also. Okay, so all these properties are really helpful. All right, so I'm going to start off by annotating something first. Okay, notice that ECD, this angle, should also be 55 degree. Because in the rhombus, these 2 angles opposite each other are the same, whereas these 2 opposite each other are the same also. Okay? Okay, so now the question asks for angle ADB. Alright, so to find angle ADB, which is here, okay, angle ADB is here. Let's draw the angle out. Alright. Of course, in this case, the best is to work with the isosceles triangle. So which isosceles triangle am I talking about? This isosceles, angle ABD. Okay, angle ABD is an isosceles triangle. So using the isosceles triangle, that would be very, very helpful. All right, so we're going to work on that. Okay, so I'm just going to put a note here. Okay, using isosceles triangle ABD. All right, now we can find angle ADB. So take note which 2 angles are equal in this triangle. These are the 2 equal angles. So you see these 2 sides are the same, which means these 2 corners at the bottom of this side will be equal to each other, corner D and corner B. All right, so remember angles in the triangle add up to 180 degree. So to find angle ADB, simple. We can just use our 180 degree minus 55. Notice that I put a pair of brackets because from here, I'm just going to straight away divide by 2 from the subtraction. Okay, so this should give us a decimal. Angles, it's okay to have decimal. So this should be 62.5 degree. Okay, so that's your angle ADB. All right. Now, whenever you found angle, it'll be a good habit to annotate that down. So 62.5 degree. Okay, let's see what's the next one. Find angle BDE. So BDE. So that means you want this corner here. Okay. Now to find this corner here, there's no straight away like shortcut or what to work out the angle. Okay, I'm just going to erase this highlighter. Okay, there's no shortcut to straight away finding angle BDE. Okay, so we got to see what other shapes we can work with at this point. All right. So if you notice, actually this right angle is something that we have yet to use, which could potentially be helpful, right? Okay. Now, previously, what we have known is that this angle is 62.5, and we agreed that this angle is also 62.5 because isosceles. So these two corners are the same. So we're going to annotate that out. Okay. Now, and we're going to slowly work our way towards, this corner. Now, so what is this corner? Do I know what is this angle DBE? Okay, this corner here. Now, actually, I do know that because triangle BCD is an identical isosceles triangle with ADB. Okay, so notice that this triangle, isosceles, the other triangle is also identical isosceles because of the same equal sides as this and these two. Okay, so remember all four sides are equal in size. So in other words, I can be very sure that this corner is also 62.5. Okay, another way to see it, some of you maybe you see it as the Z-shape property. This line parallel to this line. So if you use the Z shape, you see what I'm tracing out? That means if this 62.5, here also 62.5. So you can see that way also. All right. Now, and we also know this is a right angle over here. Because it is a right angle, this one confirm is a right angle, 90, 90, 180 on a straight line. All right. Can you see now finding angle BDE is really simple because you can work with triangle BDE. You have these two corners really. All right. So I'm just going to zoom this out. Okay, so now we can say that using triangle BDE, so using triangle BDE, I can now use 180 minus these two corners to get the angle that's required. So it's really just applying your properties. Whatever properties you have learned, apply those. So this gives us 27.5 degrees. Okay, so that's it. That's your angle BDE. All right, so I hope this is clear. Okay, I'm going to move on to question 12. A tank was completely full of water at first, completely full. Water was drained out of the tank from 2 p.m. So notice the graph here, 2 p.m. This was the water from 2 p.m., but it's slowly decreasing because you're draining water out. Okay, so that's a given. Now the line graph shows the volume of water in the tank from 2 to 8 p.m. Okay, so what was the decrease in volume of water from 5 to 6 p.m.? So we want to find the decrease from 5 to 6. So we're going to look at the points 5 to 6 first. So at 5 p.m., all right, you must be clear how to count the intervals. So this is 1, 2, 3, 4, 5. 5 gaps. 5 intervals is 20 liters. So every interval is actually 4 liters. Correct? Because 20 divided by 5. All right, so this is how you calculate. Every one interval, maybe let's just go and note at the side. Okay, every one interval is actually 20 liters divided by 5 intervals. So every interval you jump by 4 liters. Okay, so that's what it means. All right, so let's look at 5 p.m. At 5 p.m., what is the current volume in the tank? So at 5 p.m., you see after, this is a one gap after 40, so it's actually 44. All right, so this is a 44 liters. Maybe let's just put notes there. Okay, 5 p.m. this is 44 liters. And at 6 p.m., this is one gap below 20, so 20 minus 4. So this will be 16 liters. All right, so from 44 liters drop to 16, simply just subtract to get the decrease in volume. Okay, so there's a drop of 28 liters. Okay, so that's pretty straightforward still. Okay, the next one. At what time was the tank half filled with water? To know what is half filled, you first need to know what is the total capacity of the tank first. So to do that, remember, first sentence already says the tank was completely full at first, which also means if I look at first, starting from here, right before 2 p.m., or even you can look at 2 p.m., not an issue. Okay, at 2 p.m., this was completely full from the beginning, before I start to drain water out. So if you look at 2 p.m., what is the volume here? So this will be 84, then up again, 88. Okay, so that means at 2 p.m., this total capacity was initially 88 liters. So to find out what is half filled, basically you need to take half of 88 liters. Okay, so tank capacity, maybe I'll just go and note down. Tank capacity initially was 88 liters, full tank. So if it's half filled, means 88 liters divided by 2. Or you can take half times 88, also can. So now let's look at where is 44 liters. Just now remember we had 44 liters here. All right. So right now, 44 liters it's at the 5 p.m. mark. So there you go. At what time? So it's actually 5 p.m. Okay. Now the next one, how long did it take for the tank to be empty? Okay, so how long did it take? So remember from the beginning, 2 p.m. This was it was fully filled at first. And for it to be empty means the graph will slowly go down until it hits 0 liters. 0 liters of water inside the tank. Which as you can see is actually the 7 p.m. mark. Okay, at the point of 7 p.m. it starts to be a 0 liters. You don't even need to care about 8 p.m. 7 to 8 is just, it's just constant. All right, it's still 0 liters throughout. So you should use your 7 p.m. as your reference point. Okay, so from 2 p.m. to 7 p.m., that will be how long it took. Okay, so this is actually 5 hours. So that's it. 5 hours, that's the answer. Okay, I shall go on to question 13. Now, an open rectangular box measuring this by this by this is shown below. So this is the length, breadth, and height. Normally, this is the sequence that the question will write for you. Okay, the box is packed full of 1 cm cubes. They don't show it here, but just imagine that if I pack tiny 1 cm cubes into the box, okay, I want to pack it fully. Part A, how many cubes are packed into the box? Now for this question, okay, when it asks for how many cubes, all right, notice that all the cubes are made out of 1 cm cubes. Okay, so simply, if it's 1 cm cubes, you will know that along the length, you can pack 80 cubes because 80 divided by 1. So 80 cubes here. Same for along the breadth. If it's 1 cm, it's very easy to work with. There will be 50 cubes here. Same for the height, there will be 72 cubes here. All right. So if you want to find the total number of cubes, you simply multiply the cubes. 80 cubes times 50 cubes. Notice I never say cm. 80 cubes times 50 cubes times 72 cubes to get the total cubes into the box. You're not plussing. You shouldn't be adding. All right. If you add, then you're not including the cubes that can be packed within the space here. All right. So it's about volume, like if you think about it. Okay. To find the whole volume, total cubes in the whole volume, it's the same idea. Length times breadth times height. Right. So 80 times 50 times 72. Okay, I forgot to tell you all, you're allowed to use calculator because this is paper 2. Alright, so yet this will be the number of cubes. Okay, be careful of the number of zeros, it's really a huge number. Now, the next one, how many cubes touch the inside of the box? Okay, now whatever touch the inside means touch the inner walls of the box. Alright, which I think will be challenging to count because in this case, those touching inside of the box will actually be those that sticks to the wall. The layer of cubes that sticks to the wall. Sticks to the wall here, at the bottom, at the other behind wall, at the right side wall, at the left hand side wall. The top, no, because they say open. When they say open box means the top is not covered. Okay, so technically the top layer of the cube does not touch any top surface lah, because it's not covered one. Alright, so this will be challenging to calculate to find how many cubes touch the inside. Alright, so what would be easier is to calculate the cubes that do not touch the inside of the box. The cubes that do not touch the inner walls of the box. Why I say that's easier? Alright, so I need to do a bit of visualizing. I'm just going to draw out which set of cubes do not touch the inside. Okay, now the set of cubes that do not touch the inside, let's start from the bottom. Alright, we will have something like that. Okay, so what I'm going to do is I'm going to draw like a kind of like cuboid. I'm not very good at drawing, so just pardon me. This will reach the top. Okay, maybe I draw it that you all will find it easier to see what I'm trying to illustrate here. Okay, I can't really draw this very well. I'm trying my best. So just bear with me first. Actually, I should. Okay, so notice that what I've done is I've drawn like a sort of like a cuboid, red color cuboid within the big box. And this cuboid will consist of those 1 cm cubes that do not touch the walls, that do not touch the inner walls of the box. Okay, I'm not very good at drawing, but I hope you can see what I'm saying. It's like a 3D diagram. So basically, it's like another cuboid within the whole box itself. And that cuboid consisting of cubes do not touch the inner walls at all. They may touch each other, but they shouldn't touch the inner walls. Okay, so what we're going to do is we should find out how many cubes along the length do not touch the box. That means along this red line, how many cubes exist here? Along the breadth, how many cubes exist here? Along the height, how many cubes exist here? Okay, so what we're going to do is, let's start with the length first. Now the lengthwise, okay, so how many cubes should there be along this red line? So please do not say this is 80 cubes along the red line. Definitely is out. It has to be less than 80. All right, so how do I know it's less than 80? The side here, there should be 1 cube. Okay, we're talking about along the length. So by right, if I fully occupy this whole space, I should have 80 cubes. But now I'm not counting 80 cubes because I'm only counting those that do not touch the walls. Okay, when I say do not touch the wall means do not touch the side walls, left side, right side. So 1 cube taken away here because that 1 cube is touching the wall. The other cube here also touching the wall. So what you have to do is you have to take 80 cubes here, 80 cubes along the length, minus 1 cube here, minus 1 cube on the right hand side to get the number of cubes along this red line. Okay, so 80 minus 1 minus 1, which is 78. Okay, so this is 78 cubes that do not touch. All right, maybe let's just put a little title here. Cubes not touching the inner walls. Okay, whatever I do is I'm doing the cubes not touching the inner walls. So along the length, right? It will be, like I said earlier, 80 minus 1 cube on the left, minus 1 cube on the right. So 78 cubes not touching the inner walls along the length. Okay, we're going to do the same along the breadth. So along the breadth, again, same thing. One cube behind here, one cube in front here. Those one cube are touching the back and the front walls. So you should omit that out, remove that out. So your 50 cubes, you minus one at the back, minus one at the front to find along the breadth how many not touching the inner walls. So that will be 48. Okay, we're going to do the same along the height. So let me just write that down first. So along the height, now for the height, remember something, it's an open box. Okay, so 72 cubes along the height, yes, I have to minus one cube at the bottom because the bottom will be touching the base of the box. That is considered the wall also. Okay, it's touching the base of the box. Now, but the top, the layer, the very most top layer of the cube, you shouldn't minus one away because the very most top layer here, all right, it's open air. It's exposed to the air surface on top. So it's not touching the inner wall at the top flat surface here. All right, so you should just take 72 minus 1 at the bottom, minus 1 cube off at the bottom. So that's 71 cubes to place along the red line here, along the red length. Okay, so with that, we can find the total cubes that are not touching the walls already. To do this, simply your 78 multiply by 48, length times breadth times height, multiply by that. It's a huge number, 265,824 cubes. Okay, these are the cubes not touching. That means this number of cubes so big, 265 cubes, right, are inside this red color space. Okay, now remember our aim is to find cubes that touch the inside of the box. That means the space that's surrounding the red color space there. And to do this, your whole box, recall from part A, whole box can pack maximum this much cubes. But now the red box, within the red box, I can pack this much. Those that are not touching the walls, okay? So to find those that are touching the walls, basically is the surrounding around the red color part. You can just use your total cubes minus away the cubes not touching. So I'm just going to continue from here. So cubes that touch the inner walls simply will be 288,000 minus of those that are not touching. And that will give us 22,176 cubes. Okay, this is definitely a challenging question. B itself is worth 3 marks. Okay, so I hope this is clear to everyone. Okay, I'm going to go on to question 14. Okay, question 14. Now, there are some books on the shelf. 1/3 of the books are fiction books, and the rest are non-fiction. 5/7 of the non-fiction books are English books, and the remaining 16 non-fiction books are in other languages. So, what fraction of the books on the shelf are English non-fiction books? Okay, now this question, there are two ways to solve. One way is you can use model to solve. The other way is you can use ratio to solve. Okay, so depending what's your preference. For me, I think I will stick to using ratio. I think ratio actually I think it's good for this subtract question. But if you prefer to use model, that's fine. All right. But just one thing to take note, you shouldn't make the denominators the same. You should know this by now. Okay, because this denominator, all right, I think let's break it down first. Let's understand what each units represent. All right. So what does this 1 unit and 3 units represent? They say 1/3 of the books are fiction books. So obviously the fiction books has to be the 1 unit. Now, 3 units will be the total books because they say of the book. So I like to use the word of the something here. I like to use the thing that's after the word of to determine what goes to the denominator. This is just language structure. All right, so of the books means the total books is the 3 units. Okay, now 5/7 of the non-fiction books are English books. Okay, so obviously English will be the 5. All right, let's just be very clear about something. In fact, to be clearer, okay, this will be English non-fiction. Maybe I'll just put English like that, then NF non-fiction. 7, what does it represent? Again, use the word of the, what's this thing? Of the non-fiction books. So in other words, 7 is your total non-fiction books. Okay, I don't have space, so let's just put here. Just put NF will do. Okay, so 7 is the total non-fiction. So this is why I try to tell you that the denominators should not be made the same because both denominators don't represent the same type of books. This one represents the total, 7 represents only the non-fiction. So you shouldn't make denominators the same. Okay, so like I said earlier, ratio method works, fraction model also works now. All right, so both are fine. I'll just stick to ratio method since I've broken this down already. So first, fiction to total. If you want to put fiction to total, one way is you can put fiction to non-fiction. Because since they said the rest are non-fiction, you can actually easily determine the units for non-fiction. Fiction is 1. Let's put that down. Now, non-fiction will be 3 minus 1. Total minus fiction. So this is a 2. If you decide to put 1 to 3 ratio, then your title should be fiction to the total. Be careful. The correct units must match the correct title. This is important. Okay, now read on. 5/7 of the non-fiction books are English books. Okay, so this one again, I can also put a title down. English non-fiction versus the NF7. I'll use NF, huh? I will not put other languages. There's a reason for this because remember we have 2 ratio, we have to do common base. So you can easily tell already, there's a common base very quickly. NF, both are your common identity. That's why I choose to write NF here. I don't choose to write the word other languages, although I can. But I don't want to write other. If I write other languages, then this should be 2 units. 7 minus 5. Okay, but I choose to write NF because I already observed there's an NF here. Right, so this is how you quickly observe how to determine what's the title that you want to choose to put down. All right, so I'll just NF. 2 and 7 can change to 14. If you're scared you forget, write down 14 on both sides first. Underline the common base. Then proceed to multiply accordingly. 2 times 7 is 14. 1 times 7 also. Same over here. 7 is times 2 to get 14. So 5 times 2 to get 10. Okay, so once common base is done, now you can deal with the 16. They say the remaining 16 non-fiction books, are in other languages. So look at remaining. We don't have remaining here, but that's okay. Your total non-fiction is 14 units. Your English non-fiction is 10 units. So how to find the other languages non-fiction? Okay, other languages. You can just use your 14 units non-fiction minus English non-fiction, which is 4 units non-fiction. 4 units for other languages. In other words, this 4 units is the 16 books that's stated there. So you can find one unit. Oh, actually, I missed out part A. They asked you what fraction on the shelf are English non-fiction books. So actually, you don't even need all this at this point. Okay, I think all this is more important for part B. I'm so sorry. I think let's erase this first. Because why I say that? Because for fraction, you don't have to deal with the 16 at this point. For fraction, you just deal with the ratio units can already. It's simplest fraction anyway. Okay, so what fraction of the books on the shelf are English non-fiction? So first, let's identify how to create the fraction first. So English non-fiction has to be the numerator, English and F. Okay, what goes to the denominator? Use the word of the something to help you. They say fraction of the books on the shelf. So the books here is referring to the total books. So that's your denominator. Okay, so let's go on to create that. English non-fiction, as you can see, is 10 units. Remember to use the latest units. Don't go and use 5 already. Okay, so 10 units. Total books. Total means you have to add fiction and non-fiction. Do not add English non-fiction again because English non-fiction is already part of the non-fiction. English is already part of NF. So 7 and 14 add together, fiction plus non-fiction. So it's 10 over 21. I think that's the simplest form. So yeah. Okay. No, then from here, yeah, we can work with the 16 already. Okay, so just now, like I said earlier, for the other languages, okay, if you have done those steps earlier and if you don't want to erase it, right, actually that's fine. Just draw an arrow to put down the partly. Okay, so other languages, like I said earlier, non-fiction, minus away those English non-fiction to get the other languages. So in other words, for you is the 16 books that's stated here. 16 non-fiction books in other languages. Okay, so now you can find 1U. Once done, read the question. How many fiction books on the shelf? Look at fiction books, ratio here, 7 units. Okay, so 7 units is what we're looking for. Okay, so that's it, 28 fiction books. Okay, let's move on to question 15. This is on patterns. Okay, so we see a pattern here of shaded and unshaded triangles. Let's call it gray and white triangles. Follow the words here. So complete the table for figure 5. Okay, so in this case, if you notice that the white triangles, they kept increasing, but they don't increase in a constant manner, if you realize that. All right, so how they increase is like this. It's always like increase lah. This will be a +2. This becomes a +3. This is a +4. Actually, you can observe from the diagram also. You see, 1 is here, then plus another 2 to get this one. 1 plus 2 plus another 3. 1 plus 2 plus 3 plus another 4 below. Okay, so to get figure 5, I think we can obviously tell +2 plus 3 plus 4. Hence, this is a +5. So your answer here should be a 15. Okay, the pattern for the gray triangles is pretty similar. 3 to 6 is a +3. 6 to 10 is a +4. 10 to 15, which is a +5. Hence, this one will be a +6. Okay, so 15 plus 6 is 21. Okay, now lastly, for the total triangles. Now, total triangles, there's a very unique pattern. Okay, in case you can't see, this is actually a 4. It's kind of erased off. All right, so there's a unique pattern here. 4, 9, 16, 24, 25, sorry. Now, numbers like this, don't bother finding the increase. No use, okay? Numbers like 4, 9, 16, 25. These are common numbers which are used in patterns, and these are called square numbers. Okay, so I need you to write a note down. These are called square numbers. In fact, 1 is also a square number. Now, what are square numbers? So square numbers are like this, okay? For 1, 4, 9, 16. Now, square numbers means like a square. The length times the breadth. The length and breadth are the same values. 1 equals to 1 times 1. 4, 2 times 2. 9 will be 3 times 3. 16 will be 4 times 4. Okay, so these are called square numbers because two common numbers multiply together to give that number itself. All right, so if you notice, right, 4 is actually 2 times 2. 9 is 3 times 3. 4 times 4. 5 times 5. Hence, this will be a 6 times 6. Okay, which should give us a 36 here. Right, so I erase this. Okay, so this is for part A. Now, the next one. A figure in the pattern has a total of 144. So total, we can look at the last row. Then we can deal with square numbers, right? So total of 144 triangles, what is the figure number? So first, 144 triangles will be in this row, and we have to figure out what number times what number give me 144 triangles. So that's the first thing we should do. 144 equals to what number times what number? Because I'm following this pattern, square numbers. So if you're good with your multiplication, you should realize this is a 12 times 12. All right. Now, don't rush to write down figure 12, huh? Got to see what's the relationship between figure number and all these products here. Now, notice something, huh? Figure 1, this is a 2. Figure 2, this is a 3. Figure 3, this is a 4, and so on. Okay? So notice that the figure number is always one lesser than the numbers here in the product. Which also means if this is a 12 times 12, my figure number, again, like I said, figure number will be following this 1 lesser than the 12 here. So simply figure number, you have to take 12 minus 1, which is figure 11. Okay, so you gotta see the relationship. Don't just do blindly. Now, for part C, in figure 50, how many white triangles are there? Okay, so this will be a tough one. It's worth 3 marks. Now, figure 50, you're not going to write all this until 50. Impossible. Same for this 144. You cannot go and write all this until 144. It's a waste of time. Okay, so looking at figure 50, I want to find white triangles. So white triangles is this one. 1, 3, 6, 10, 15. And the difficult thing about the white triangles is that the increase is not a constant increase. It's not consistently increasing. The increase, in fact, is increasing, like plus 2, plus 3. It gets higher and higher, plus 2, plus 3, plus 4, plus 5. Okay, so then we have a problem here. We can't use intervals concept. Intervals concept is good if, let's say, the increase is always plus the same number, increasing constantly. But we can't use intervals. That's the problem here because of this. All right. So then, in this case, how do we go about doing it? Okay, we simply make use of this plus 2, plus 3, plus 4. We string it into an equation. Okay, so what do I mean by that? All right, so what I'm going to do is I'm just going to highlight out all the numbers that helps me form an equation. I think I'll use a pink highlighter. Okay, so I'm going to start off with the first figure, the first white triangle in figure 1. It's a 1. One piece of white triangle. And this, I'm going to keep on increasing numbers to it because of the plus 2, the next one. Okay, so you notice to get to figure 2 is 1 plus 2. To get to figure 3 is actually 1 plus 2 plus 3. I ignore this already, don't care about this. 1 plus 2 plus 3 to get to figure 3. Notice that? Okay, to get to figure 4, it's 1 plus 2 plus 3 plus 4. So I hope you see the pattern here. Okay, maybe I'll just write down. Do I have space? Okay, maybe I have space. I'll just do a quick at the side here. Figure 1. What's this? White triangles. Okay, so I'll just put white down. All right, white triangles. Figure 1 is just one white triangle. Figure 2, I wouldn't put 3. Figure 2 is made up of 1 plus another 2 triangles. Figure 3, you see, to get the figure 3, to get the figure 3 to get 6, right? I don't put a 6. Not important. Putting 6 does not help you. Okay, so figure 3, notice to get to this result here is actually 1, starting from here, the first number, 1 plus 2 plus 3. You keep adding plus 2 plus 3 to it to get the figure 3. So you see, I'm trying to show you the pattern by listing out this way. Which also means, can you see to get to figure 50 is actually 1 plus 2 plus 3 all the way until plus 50. See, 2, 2. 3, last number is 3. 50, last number here is 50. So this is what you should be calculating. 1 plus 2 plus 3 all the way until plus 50. Okay? Now, but again, to calculate this, you're not going to press your calculator, one by one to press all the numbers in. It's a waste of time. All right? So over here, matrix math, what we have taught you is called the reverse series method. Okay, so I will show you and illustrate to you what is the reverse series method. Let me just draw a break line here. Okay, now this is what the reverse series method is about. So I will write down the equation. I will include the last 3 numbers, so starting from 48, 49, and 50. Now, and what I'm going to do next is to write out the same expression Okay, I'm going to write out the same thing, but this time in the reverse order. 50, 49, 48. When you all write it, try to write it such that each number is directly underneath another number at the top series. Okay, like this. Now, this reverse series method is very helpful because you should observe that actually, okay, I'll just box this up. Actually, can you see that each pair of numbers gives you the same sum? You see, they give you the same sum always. 50 and 1 is 51. 49 and 2 add together is also 51. 48 and 3 add together also 51. Okay, so notice it's always 51 throughout, right? Okay, so now I need to think how many 51s are added throughout. Okay, so sorry, because let's do the first step first. Okay, we need to write all the steps to be awarded marks. All right, so we can say sum in one pair of numbers. One pair is the light blue box that I've boxed up. Sum in one pair, just choose any pair. You want to use this or you want to use 49 and 2, also can up to you to do the equation. So I'll just choose 50 and 1. Okay, so sum in one pair is actually the sum of 51, which I've listed down here. Now, how many pairs of numbers are there? So notice that this is one pair, two pair, three pair, all the way until the last one. So there are 50 pairs of numbers. So we're going to find the sum across 50 pairs. Okay, I don't have space, so I'll just continue here. Okay, sum across 50 pairs of numbers, which is actually 50 times 51 because there are 50 groups, 50 of these boxes throughout. Okay, just follow the top number 1, 2, 3, these 3 boxes. So all the way until here is 50 boxes throughout. So there's 50 sets of 51. So 50 times 51, 2550. Okay, so the sum across is 2550. Now we call this sum across two series. So this 50 pairs is also known as two series because this thing is one series. Bottom reverse one is the second series. So there are two series throughout. So when you sum up 50 pairs of numbers, right, you're actually finding the sum of everything here. And that also means the sum across both horizontal series. Okay, so this is also known as the sum across two series. So let's just put a bracket there. Now, in other words, now I can find the sum across just one series will do. Because I only just need one series actually. Sum across one series of numbers. And to do that, your 2550 you can simply divide by 2 because this first series is exactly the same as the bottom series. Since the numbers are same numbers that is being involved in the addition, it's just I rewrite the second series in the reverse order. But other than that, the numbers presented there are all the same thing. That's why I can simply use 2550 divided by 2. Split it across two series. And that gives us 1275. So since we are only interested in the sum of 1 to 50, which is one series, there you go. That is your answer. 1275. Okay, this is definitely challenging, but we call this the reverse series method, which is actually pretty useful in finding the sum of many numbers. Okay? Okay, now let's go on to question 16. I believe this is the, oh no, still have. Okay, 17 is the last one, is it? Yeah, okay, let's go to 16 first. Now, all 43 students from a class were assigned to welcome visitors at a school event. They were to line up in a row from one end here to the other end of a corridor, equal spacing of 1.2 meters apart. How long was the corridor? Now, I'm sure you all can tell what concept is this on. This is your intervals concept, okay, which we have done many times during lessons also. Okay, so first, we know there are 43 students. So you gotta first find out how many intervals are there across 43 students because I already know every interval is 1.2, right? So to find number of intervals, remember you can take 43 minus 1. Just take position minus the position here. Last minus first position. All right. So 43 minus 1. In other words, you can think of it as the intervals is always one lesser than the people. If you don't know why, just think of your fingers. You stick out three fingers, you notice that your three fingers creates two intervals. Interval is the gap, the spaces. So three fingers creates two space in between. Four fingers creates three spaces. So the number of fingers is always one more than the gaps, the spaces. Okay, so it's the same here. 43 students should create 42 gaps in between them, across them. So this is 42 intervals. Maybe let's put a note down. Now, since every interval is 1.2 meters, okay, I think we can write that down first. One interval, just put INT for short, is 1.2 meters. Now, but remember, across the whole corridor, it's actually 42 intervals. So then you can find the distance across 42 intervals already by multiplying. This should give us 50.4 meters. That's the length of the whole corridor. Okay. Okay, we shall move on to B. Now, on the day of the event, 6 students did not turn up. As a result, remaining students had to line up from one end to the other end at a new equal spacing. Now, so you just imagine, like, if 6 people never turn up, then the remaining students rearrange themselves to form new equal spacing. It tells you that the new spacing must be larger than 1.2. They must be all be further away from each other. Because lesser people means create larger gap already. Okay, so later your answer new spacing must be bigger than 1.2 for sure. This is how you can check. All right. So first, let's find out how many students remaining first. Okay, number of remaining students. I'll just put remaining people for short. Remember, there are 43 people right initially, but 6 people didn't turn up. So 43 minus 6. So 37 people. So these 37 people must now rearrange themselves to create new spacing. Now, but there's something that didn't change. The corridor didn't change. So remember that the total length 50.4 meters for the corridor still stays the same. It's just that now each person stands further away from each other. Okay, which in other words, 37 people again find out the number of intervals first. So 37 minus 1. Now there are 36 intervals. And these 36 intervals will be spaced out. But what is the total distance? This 36 intervals is still the 50.4 meters, the whole entire length of the corridor. No change in the total length. Okay, so now you can find out the new spacing, which is the new one interval. So this is where you do the division. So the new gap is a spacing of 1.4 meters. So that's your answer. Okay, so that's the new spacing between every 2 students. All right. Okay, we'll move on to the last question, question 17. The table shows the charges for renting a bicycle. So notice they split across weekdays and weekends. Timing also, there's a price difference. Okay, so John rented a bicycle from 10 a.m. to 1 p.m. on Sunday. Okay, so easy lah. Sunday, we just focus on weekends lor. Don't care about weekdays really. How much did he have to pay? All right, so 10 a.m. to 1 p.m. on Sunday. Okay, so let's find out what's the duration first. So just draw a simple timeline like that. 10 a.m., 11, 12, 1. So that's 3 hours. Okay, so during the 3 hours, he rented the bike on Sunday. But look at weekend pricing. Okay, luckily 10 a.m. to 1 p.m. falls within this time range lah. Weekends is easy because it's just one single time range given. So it's $8 per hour. Okay, so no problem. $8 times 3 hours. Okay, so this is the amount he paid for the Sunday. Okay, now on Tuesday. So Tuesday is a weekday, weekday a bit more challenging because got two different pricing. Ken rented a bicycle and he only returned it at 7 p.m. He paid a total of $29. What was the earliest time he rented the bike? Okay, so he returned at 7 p.m. Now you notice 7 p.m. Should fall within this time range already. All right. So in this case, since he returned it at 7 p.m., you look at this time range, we're going to work backwards to find out how much is he being charged in the more expensive category, the $7 category first. All right. So you have to start from 5 p.m. Use 5 p.m. as your first point of calculation. 5 p.m. to 7 p.m. Since he returned at 7 p.m., don't go and use 8 p.m. 5 to 7 p.m. Okay. So 5 p.m. to 7 p.m., which is 2 hours. Correct. So this amount that he's paying for this 2 hours is $7 times 2. So that means he's paying $14 for the more expensive category. But if you read the question, total he actually paid $29. So it must mean that Ken rented the bike before 5 p.m. He must have rented for more hours prior to that, before that. Okay, so what you can do is you can use your $29 minus away the $14. So what does the $15 mean? This $15 has to go to the first category, the cheaper category. And this $15, notice that it's actually in the category of $5 per hour. So now you can find the number of hours rented in the cheaper category, which you can use $50 divided by the $5, which means 3 hours. So what is this 3 hours? Like I said earlier, this 3 hours is the cheaper category here. Okay, okay, sorry, maybe I shouldn't highlight the time, very confusing. Okay, I'll just highlight like the box here or something. Okay, so now working backwards these 3 hours, remember just now we use 5 p.m. as the break point, right? So 9 a.m. to 5 p.m. is $5 per hour. So for during the 3 hours, you gotta work backwards from 5 p.m. You shouldn't use 9 a.m. There shouldn't be a jump to 5 p.m. here. So work backwards from 5 p.m. Okay, so 5 p.m. you work backwards. For 3 hours simply means it started at 2 p.m. He started renting at 2 p.m. So this is your earliest time that he has rented the bike. Okay, so that's the end of the paper. Thank you very much. I hope this has been helpful.